retailers and what is the revenue loss that can happen if their site is down for an hour, for a minute. Okay, so now slowly you might get an understanding why we want to go with a modular way of developing our applications, be it backend or be it front end, and that ties to this conversion funnel strategy. Okay, so there are various ways to build micro frontend, right? As I said, iframe is one of the way to build micro frontend, but there are 11 different ways you can build micro frontend. Trust me, guys, there are 11 different ways. And even before 2013, the micro frontend was in existence. Okay, it started with the monolith, the iframes, the Jamstack, server-side composition, edge-side composition, client-side composition, build-time composition. There are 11 different ways with which you can build micro frontends. But don't worry, I'm not going to take a session on all the 11 different types of micro frontends. So today the focus is more about okay, so today the focus will be more about the build time composition and the runtime federation. Okay, before we get into further details, right? So we will we will continue the session with a virtual use case. Okay, so Visa Foods. So this is an online home ordering website, and this is their current state architecture. So they have built a platform for home food ordering through online. Okay, and today they have a micro services based backend development, and they have one big monolith in the front end into which people can serve for the online food. They can order it and they can track it. But the C-suite executives, they wanted to take this business to a next level, wherein they want to launch this product across cities and not just stop with home food ordering. Rather, they wanted to take it for restaurant ordering, and they also wanted to do groceries deliveries. And they also have a non-functional requirement that this site should be up and running for 24/7. Okay, so this is the roadmap that Visa Food has, and this is the use case that we will take it and we will apply to our micro frontend principles. Okay, so there are two ways with which we can attack this problem, right? So one, we can have a monolith, put the monolith into server and scale the monolith application into multiple servers or multiple Kubernetes containers, and the application would be scaled. But still, right, there are certain problems. So if I want to roll out a new feature for a grocery delivery or to view the catalog of grocery, when I do a monolithic deployment, it will impact the cart and checkout. Definitely there is going to be a downtime at least for a few minutes, and that is going to cause a revenue loss. So how can I isolate this problem? So now you all might have known the answer. It is micro frontends, where I'll be splitting the applications and I'll be deploying these as a modular application. Certain applications will take care of payments, cards, checkouts, and certain applications is going to take care of the food catalog, menu, and such. So we are clear. But how can we build this? So there are two ways, as I said. One is doing a runtime composition. The other one is doing the build time composition, right? And when you type micro frontends in Google, the professor Google always says micro frontend is always a module federation or a runtime composition. So you hit Google with micro frontend word and you will get all the top results as module federation. But that's not the only way of building micro frontends, right? So we'll start with runtime federation. Okay, this is the runtime federation slide, right? So the backend is still going to remain the same with the modular microservices approach. In the front end, we are going to split this front ends as 4 different front ends. One is going to take care of search, the other one is going to take care of cart and ordering, third one is about account management, and fourth one is about tracking. So this is how we are going to split the micro front ends. So we are very clear, it is going to be micro front end, and we will have separate web applications in one of the technology, maybe in Next.js or Remix or whatever it is going to be a separate web applications. But the caveat here is each of this web application would require components to be shared across each other, right? So for example, in this screen, you see an order summary page and you also see a tracking. These two comes from 2 different micro frontends. How am I going to stitch these pages? So that is going to happen in runtime, like how we use APIs to get the data. We use a web URL calls to get the remote JavaScript component, and then we will be stitching the pages. So this is how runtime federation works. So we never know who the developer is. All we know is the URL or the endpoint, the JavaScript endpoint. So we will just use that endpoint to get the component and then stitch it into the web page. So this is how runtime federation works. Everything is going to be using the web URLs, and the remote components will be consumed by the host application, and then they will paint the page. Okay, so now we have 4 different applications. How are we going to stitch all this together and provide a single point of view to the consumer, right? So we need something to do that, and that is called as the shell micro frontend. So in front of all these micro frontend applications, you will have a shell micro frontend application. It is nothing but a kind of a gateway. Again, it is going to be a React or your JavaScript application, which will pull the components from the micro frontend. So in this approach, even the entire page is considered as a component. The shell micro frontend would pull the components into the shell application, and it will provide the response to the end user. So this is how it is structured. The key takeaways with this approach is, right, so you don't need any deployment when the component changes. So each team is highly independent, and they can roll out their new features, and any changes to the component or to the page, there is no deployment that is needed. Okay, but the drawback is the shell application or the shell micro frontend, it is going to create a single point of failure. Okay, so that is a drawback of this particular application. And the other one is these runtime federated applications are purely client-side render. Okay, so any idea like what is client-side rendering and server-side rendering? Yep.
Yeah. The assets will be loaded in the browser itself. So what it will do is it will load the build, and all the routes and everything will be loaded from the assets that it fetches. Whereas in the SSR, it will the server will render the complete HTML page and give it to the browser.
There you go. So this supports only client-side rendering, but we are talking about a B2C website where if someone gets into Google and if they type idli sambar or dosa sambar, my website should be listed first, right? That is not going to be supported by this approach, because that needs your application to be rendered on the server side. Only the server-side rendered apps are SEO friendly, and it increases the ranking for your application. So this is not going to suit that. Okay, but where exactly this fits, the runtime federation, where exactly this fits, right? So the top retailers, they still use runtime federation, but not with the approach of having a shell micro frontend, rather just to share the components. Again, let's take this example, right? I said Amazon. Within Amazon, when you go into the details page, for electronics, you get the details about the mobile phones, the processor, the type of camera it has. But if you get into the textile section, it tells you the material, the sizes, right? So how they differentiate. Internally, everything is a different microservices. The page will be different. The pictures will be different, right? So these things happen via a runtime federation, where just that component, right? So that will be pulled from the remote host during runtime. But the entire application is not a runtime federated application. So that's the difference, and that's where it excels. You cannot build the entire platform just with runtime federation because of the drawbacks that I just mentioned. Now let's get into the build time composition, right? So, okay. So with build time composition, the key difference is the way how you share the UI components or the JavaScript components on the front end, right? So in runtime, it is very clear it is going to be in runtime, but with the build time composition, so each of the teams, they will be building the components that needs to be reused across. So you might have seen the recommendation carousels in Amazon or any other e-commerce website like Flipkart, right? So you might have seen a recommendation carousel in the cart page or in the checkout page. So that will be developed by a separate team, and they will be publishing that as a NPM package. So if you see in the middle, right, so everything in yellow color in the middle box, all those are reusable components that are created and published into a package manager. So once it is published to the package manager, there will be a catalog, and the teams can pull the components as needed during their development phase or during